Hi, my name is Iz, and my project is called Composite Wing Spar, Modeling Subsonic Loading Capacity. My project can be broken down into two parts, but today I will only be focusing on Semester 1, Modeling the Spar, using computer modeling techniques to model a composite wing spar. Geometry of the spar. The wing spar we modeled could be used in the wing of a large model airplane. It is 40 centimeters long and 20 millimeters tall. Each flange is 10 millimeters wide, and with a web depth of 2 centimeters, the whole spar is 22 millimeters wide. The spar was designed using MathCAD Prime 3.0. On the right, you can see a graph representing the spar in real life. It is plotted on an XYZ coordinate graph system, and the flange and webs are labeled. Material placement in the spar. Each lamina is 1/3 of a millimeter. There are 6 laminas and 3 directions of laminal fibers. The fiber layers are symmetrical from the center of the stack. The web and flanges all have the same laminal fiber directions, as well as the same number of lamina. On the right, there is a graph that represents each layer and the angle of the fibers in that layer. Notice that there are 6 layers, but the last is labeled 5. This is because in a matrix, the origin has to be 0, and that's how I had to represent the layers in MathCAD Prime 3.0. Stiffness properties of the composite. On the left, there is a graph that represents the values of each of these stiffness properties. They are all in gigapascals, but they are not comparable to one another. E1 represents Young's modulus parallel to the fibers. E2 represents Young's modulus perpendicular to the fibers. G12 represents shear stiffness, which is the same in both directions. On the left, there is a graph representing the strength properties of this composite and their values. They are represented here even though they are not comparable to one another. XT represents tension stress parallel to the fiber. XC represents compression stress parallel to the fiber. YT represents tension stress perpendicular to the fiber. YC represents compression stress perpendicular to the fiber. S represents shear stress, and all units displayed here are in megapascals. Notice that all X variables represent a stress parallel to the fiber. All T variables represent a tension stress. All Y variables represent a stress perpendicular to the fiber, and all C variables represent a compression stress. Here are some difficulties that I had with my project. My computer struggled to define the web in terms of an axis where the laminal layers angles would be considered undefined. I fixed this problem by defining the web in terms of another axis. I also struggled with being able to define the spar as a whole, instead of just in pieces set on one another. I determined that this would be okay for testing purposes because a break would not first occur along the edges of the web. Conclusion. I was able to design a wing spar with these specifications. I was able to use a computer program called MathCAD Prime 3.0 in order to complete these tasks. In order to create the visual of the completed spar, I used a program called SketchUp. I plan to expand my project by testing to see how strong this spar is compared to a traditional aluminum spar. I may also test other types of composites as a material for the spar.